We're now going to graph an ellipse based upon its equation. We're given 4x squared plus y squared minus 8x plus 4y plus 4 equals 0. We need to discuss the graph of this equation, so what we're going to do is first complete the square in the variable x and y. So we do that by grouping the x variables together, and I'm going to group the y variables together. And I'm going to get the constant on the right-hand side of the equal sign by subtracting 4 from both sides. Now before I complete the square in x and y, I want to factor the 4 as a common factor out of the x terms. So I'm going to have 4 times x squared minus 2x, and then I'm going to have to add some quantity to complete the square. Then plus y squared plus 4y. I'm going to have to add some quantity here to complete the square, and that's going to equal negative 4. So the question becomes, what do I need to add here to complete the square in x? Well, remember, we're going to take half the coefficient on x, so half of negative 2 is negative 1, and square that result. Negative 1 squared is 1. Remember, though, we've added more than 1 to the left-hand side of the equation because this 1 is being multiplied by 4. So technically we added 4 times 1, or 4, to the left-hand side of the equation. Therefore, I need to add 4 to the right-hand side. Now we're going to complete the square in the variable y. Half of 4 is 2. 2 squared is 4. Here I added 4 to the left-hand side, so I'm going to add 4 to the right-hand side. The result is that I get 4 times x minus 1 quantity squared plus y plus 2 quantity squared equals negative 4 plus 4 is 0, plus another 4 is 4. Now my equation is not in standard form. I want the equation to be set equal to 1, so I divide all 3 parts by 4, and the result is x minus 1 quantity squared, technically over 1, plus y plus 2 quantity squared over 4 equals 1. So here's what we should notice right off the bat. The larger value is in the denominator associated with the y term. Therefore, the major axis is going to be parallel to the y-axis. What I have is the center of the ellipse is at 1 comma negative 2. H is 1. K is negative 2. I have that b squared is equal to 1, and c squared, and a squared is equal to 4. Remember, b is the value in the denominator of x here, and a is the value in the denominator of y. Now what I can do is use this information to find the value of c. We know a squared, we know that b squared equals a squared minus c squared, so 1 equals 4 minus c squared. That gives me that c squared is equal to 3, which means that c is equal to plus or minus the square root of 3. Now let's find the vertices and the foci. To find the vertices, I remember that my major axis is parallel to the y-axis. So the vertices are going to be located above and below the center. That means that my vertices are going to have an x-coordinate of 1. Then I recognize that the value of a is 2, and a equals 2 is the distance that the center is from the vertices. So I'm going to go 2 units above the center to 1 comma 0, and 2 units below the center 1 comma negative 4. For the foci are also located above and below the center. The value of c is plus or minus the square root of 3, so I'm going to go square root of 3 units above the center and square root of 3 units below the center for the foci. Now what I need to do is use this information in order to help me graph the ellipse. What I'm going to do is label my center at 1 comma negative 2. So there's my center. I have one vertex at 1 comma 0. I have a second vertex at 1 comma negative 4. I have foci at 1 comma negative 2 plus the square root of 3, which is right around there. I have another focus at 1 comma negative 2 minus the square root of 3, which is right around there. Finally, I need to use the value of b to determine how many units left and right of the center I should go. Remember, b squared was equal to 1, which means b is equal to 1. So if I go 1 unit to the left of the center and 1 unit right of the center, one unit right of the center would put me at 2 comma negative 2. 1 unit left of the center puts me at 0 comma negative 2. I now have enough points on the graph in order to shade in a nice graph of the ellipse. So here is the graph of our ellipse.